Hey guys, alright, so I promised I'd do some instruction on how I did the CO2 laser. So here's some real quick pointers. It's really not that difficult, but there are some crucial bits that I think if you saw what it is you're trying to accomplish, it would be a lot easier. I do have some printed mounts that I've made for the mirrors 2 and 3, but that's actually a good point. In the system, you're going to have a laser tube. This is a 40 watt tube. It's fairly short. The higher wattage tubes you get, the longer and longer they get. If you go for something like a 100 watt tube, it's as long as this table from here all the way over to there, a little over 1200 millimeters. So think about that before you go, I want something bigger. The tubes get bigger. These nice mounts on Amazon, they're on my Amazon list, go all the way up to an 80 watt tube because they also get bigger around as you go, which is something I'm looking at doing. It'd be kind of nice to have a little higher wattage tube. So we have mirror 1. It's the only static mirror in a 3-mirrored system. I have 4 mirrors, so we won't talk about that just yet, but you don't have to. But that's the static mirror that aims at mirror 2. Mirror 2 is on the y-axis, or, depending on how you build it, could be the x-axis. And then mirror 2 shoots over to mirror 3. Mirror 3 is what puts it into the focal lens and down to the work surface. How best to start? So I designed this whole the MPCNC using the Burley parts. I downloaded them, and then I just put them in place in Fusion. So I took Fusion 360 and I went ahead and built up a mock-up of this entire table, including my IKEA dinner table I mounted it to. Took all the dimensions, mocked up the pipes, and assembled it all just the way it would be in real life, so I could figure out what point would be level for this mirror with this mirror so that it followed this pipe. By the way, you don't care if it's level to the ground. You care that it's in line with this pipe because this pipe directs the travel of the gantry back and forth. That's what this mirror is going to do, is whatever this pipe is doing. And so really, that's what I used. I used this top piece of my fake pipe to give me a place I can mount and then make sure that this mirror is exactly at the same height. And then of course, I wanted to make sure that it's in the line from here all the way to here. And that's important because while you can adjust these mirrors and make them point pretty much anywhere, you need to make sure that you have a line that is perfectly parallel to this pipe. And that's the ultimate trick. It's got to be perfectly parallel to this pipe. It cannot waver. If it wavers at all from perfectly parallel, then it's going to change position on this mirror as you move back and forth. So no matter what you do, what you did to line it up, if it leaves this mirror that isn't parallel to this pipe, when it hits this mirror, it's going to walk as this gantry moves back and forth. And that would be bad because if it moves here, then it's going to move in your laser focus. And the one thing you don't want is you don't want it to get off down here and have it start heating up that nozzle. Well, that's smart, and it robs all your laser power. So doing things like putting a piece of tape over this piece of mirror mount and then watching it. You start a small low power burn on the piece of tape, and then you move the gantry around to all its possible positions, and you fire again and try to get it to hit the same place twice, making minor adjustments. Now there are videos, and I'll try to link to them because apparently my new YouTube channel allows me to link to other people's works. I'll do some searching for laser aiming videos so that you get a lot of different material to remind you how all this works, because I may not explain it the best way for you. The same deal goes with mirrors 1 and 2. You got to make sure that you're hitting the exact same dot on mirror 2 from mirror 1 so that when it moves back and forth along this pipe, this pipe here now, this line needs to be perfectly parallel to. And that's all you're trying to do. After that, from that point, it matters not where the tube is put. Obviously the tube works better horizontal than vertical, but it can be anywhere. As with this mirror that I've chosen to use, I could have put that anywhere. Because ultimately, once it hits your first fixed mirror that needs to be in line with the first moving mirror, where the beam came from matters not. Because at that point, you need to make it parallel to your perpendicular to your axis. And that's really it. So it's really cool to do this when you've got the laser running full time and you can watch it in real time. Now you can't do that with CO2. It hurts, and it hurts a lot. I've never done it. I haven't gotten anything accidentally in the path for as long as I've been running this laser. So I call myself very fortunate because it is a very open system with no guards. But I used to work around one. I did CNC laser scribing for 6 months with a 650 watt CO2 laser cutting ceramic chips. And it was an open system. So we had engineers that had large 3-inch marks on their arms where they accidentally passed their arm through the beam. I never wound up with one. So far so good. So getting this mount solid would help a lot. But then what I did is I bought this extra. This was $117, by the way, at the time I bought it. It comes with a little laser, spotter laser, and you can see the spotter laser is turned on right now. So if you look down here, the spotter laser is active. And it bounces off this beam combiner that lets the CO2 pass straight through to that mirror, as well as bounce the laser off, or the LED laser off, and follow the same path. And I took the time with a piece of target paper here to get the LED laser and the CO2 laser nice and matched up. And that allows me then, because you can see where on the mirror it's hitting. It's nowhere near centered because that's not important. I tried to get it as centered there so I had more mirror to play with to get things aligned. But once I had it where I could use the LED, 5 milliwatt beam, then it was a lot safer for me to sit there and get things all aimed so I wouldn't accidentally fire the CO2 and have it come strafing off and, I don't know, tattoo the neighbor's dog or something. But I used, if you look at the table here, here's my cheat, you'll see these 2 screw holes. So I screwed a flat piece of board and stretched a piece of string that went right along the center of this guy all the way to the back, and there's another one on the back side, and I used that to aim my mirrors. And I got it to where I can move this gantry right here full throw and have the line always stay over the exact same scratch mark on this. You see, there's a little scratch mark right there. And I made sure that the line was under that scratch mark the entire time. And that gave me my true line of sight. So I could actually line up the fixed mirror at the end. And I just set it underneath so the center of the mirror was on that little line. It's a little harder to do on this one here. This one here, the mirror mount, as well as the mount here, all of this was built in Fusion. I did no outside physical alignment with that at all, and it just worked. I highly recommend it. It'll save you some time. If you want my file that has Fusion with the table all built up, I'm happy to give it to you. I talked to Ryan about it. It gives away no proprietary secrets, since all they are his STLs, not the source files. So you're not getting anything you couldn't build yourself. But since I built it up, I'm happy to save it. One other thing that helped me out a lot is, if you notice, my tubes, they're galvanized. If you look at my tubes, these are galvanized. They were easy to get. I got a whole bunch for free from an electrician that's a member of my ham radio group. but they suck for lasering, because this moment arm that brings this mirror out, while it's stable, it feels really good. Any vibration between this bearing and this surface is amplified, so that when the y-axis is in motion, going back and forth this way, you'll see a little bit of vibration in the laser hitting the target on that mirror 3. And while right now I've got it down to where it's not bad at all, I took really fine sandpaper and sanded the crud out of this particular run right here. It has calmed down quite a bit. Oddly enough, this one over here didn't cause as much problem, but I sanded it anyway. It was really this one here that caused all the vibration. So yeah, stainless steel tubes, awesome if you're going to go for laser. Not so much on the galvanized. This tube here and these tubes here don't matter. If this guy vibrates a little bit, he is not going to cause any problems on the focal lens, because the focal lens is vibrating with him. So it's barely any change in movement. I did separate when I bought this kit on my Amazon list. There's a cover tube that covers this. I sliced it off even with the mirror so that I could separate the Z-axis, so that I could keep my Z-axis going up and down, and that gave me the ability to use woods of any thickness or to tune my laser focal point. I could actually use the part in Lightburn that allows you to drop your laser Z and carve deeper into a piece of wood after you've cleared the curve. So I can do in a more automated fashion cutting of thicker material. Now, I played with it a little bit just to make sure it worked, but I haven't really done much with it yet. But that's what you're looking at. And so when you line these things, you're going to be using a lot of Post-it notes, that's what I used, to cover up the mirrors with little drawn crosshairs. And you're going to watch, not so much from here to there. Here to there, you could care less. That could be directly laser to there too. You don't have to have another mirror there. What you care about is firing from here to here and moving that Y back and forth, and get it to the point where the dot here does not move. And then you'll do the same thing from here to there. If you've truly made this dot not move at all, then it won't matter where on the Y you are when you start getting mirror 2 to mirror 3 done, because it'll be an independent system. And then you'll do the same thing. You'll put a piece of Post-it note or something up there. White masking tape works really well. And you'll sit there and fire the laser, or if you've used a spotter laser like I've got, you'll fire the laser and see where you're at and make sure you don't move as you move back and forth. This is a 630 by 945 working area, and I can draw a box all the way around it with the gantry and still have a usable laser coming out the tube. It gets a little rough right over here still. I got some more tuning I can do, but it works really well right up here. If I have some hard material that I need to cut through, I'll do it up in this quadrant, because the beam itself is at its absolute shortest. I've got the mirrors close together, so I'm getting more and more of the power aimed at my work. So that's kind of what the talk about mirror alignment and where you save yourself time. And where I save myself the most time is from this mirror to that mirror and down, is by mocking it up in Fusion and building the 3D printed mounts digitally, so that they came out within a millimeter of dead perfect. Even with a little bit of printer error, it came out right on the money, and that's what saved me the time. So of course, my mounts are for other kinds of, are the 3.25 inch American electrical conduit. If you're using 1 inch stainless steel or anything else, you won't be able to use my mounts directly. You'll have to modify them yourselves so that they meet those requirements. And to do that is real easy. I give you guys the source files, mock up your exact MPCNC, and then making any kind of mods becomes very, very easy. And that's a quick talk on mirror alignment. I'll see if I can do better with the digital files.